Hi, everyone. So we're going to do Grasshopper today, which is the kind of parametric and computational part of Rhino. And it's there are different ways to kind of use it, which I'm going to try to explain with some slides. So one, I just thought I'd put it in there. When I was in London studying, I was pretty close, 5-minute walk from the British Museum. And the roof of the British Museum was designed with kind of computational design, and they sort of wrote their own software to create this roof. Here it is from above by Norman Foster Architects and Bureau Happold. And one sort of antidote I've always remembered, which was about originality and creating your own tools. So the logic here was that if you use the tools, the off-the-shelf tools, there are only so many things that you can do with those tools, and you end up sort of doing what everyone else is doing. But when you create your own tools, which in this case, they're writing their own software, they sort of could do things that nobody else could do. And Grasshopper, in a sense, allows you to go beyond the standard components of 3D modeling and kind of create your own. If you think of the file that you create within Grasshopper as a tool, you're kind of writing your own custom tool, which is sort of your original tool, creating sort of uniqueness within 3D modeling. So this is an example that you probably know already, which I'm just going to go through. We could draw a box in 3D, explode it and delete two surfaces from the sort of poly surface, create a triangle on the top and a triangle on the side, and then do a sweep to surface using these two as rails, these two edges as rails, and these two edges as the cross sections. That, drawn in Rhino, would not be adjustable in any way. We could scale it, which we could make. It is currently permanent, and we could scale it, making it a permanent change. Grasshopper, it will be red if not selected, green if selected. I just did the screen capture when this was selected. But Grasshopper we kind of organize it in a different way, and everything is flexible. So we can change the edges, the width, the height, and the same thing, the same model can then adjust to any sort of settings we give it. We're going to do some surface divisions as well, which will be, and the contour, which you could then put the number of floors as a variable and just a slider to change the number of floors and organize your model differently. So an example of where this would be useful is if you did a Grasshopper file for an iPhone cover. It would just be a matter of adjusting a few variables when the new iPhone came out and the size was slightly different, as opposed to starting a new 3D model from scratch. So you could possibly adjust the settings within a minute flat, and then you'd be ready to print that model. So a story which I love from the TED Talk, Trial and Error and the God Complex by Tim Hartford. He recalls this story from the 1960s where they were struggling with creating this nozzle for a soap detergent company, and were wondering what was the best design to do that. And the God Complex is sort of being confident with sort of, I'm smart, I'm intelligent, I know what I'm doing. And they created this nozzle and said this was the good, perfect nozzle. And this ex-geneticist, Steve Jones, came along and says, no, I want to do this through trial and error, and created 10 variations of the original nozzle. And so one variation was better, created 10 variations of that variation, and kept going until he was 400 variations deep. This is in the 1960s. And then had no idea why, but this nozzle just worked better than all the other nozzles. And it's a sort of different way to think about design and engineering. And Grasshopper, based on its variation, is a great way to sort of do a design and create lots and lots of variation and see which one's better through trial and error. At a sort of very elite end, this is from Arab engineers. And if most people, when they think about 3D modeling, they think about this object on the left, and this is sort of a steel connection. When you leave the variables not up to something a human might set, but as a sort of a computer would just go plugging in variables and trying to get to the lowest amount of steel and highest amount of strength, that it sort of gets to this middle object and then onto this object on the right, which is less steel and does all the same tasks of the steel node on the left. So it's sort of producing a lot of variability, a lot of optimization. KPF, I mentioned before, is where I kind of started my first job, and this model was in the office when I started, and they kind of produced this facade at the bottom, which is just a lot of skyscrapers want to protect pedestrians from the wind. Wind basically blows on the edge of a building and then blows downward. And one way to do that is the New York wedding cake design, where wind will only go down to the sort of tier. This is a different way of producing the skirt at the bottom of the building. And we'll look at sort of a way to think about doing this kind of skirt design when we open Grasshopper. So a lot of it is thinking in terms of lists, and here's an example that I did in Python, but it's the same logic as Grasshopper, where if I have 4 points, points generally start from 0, so it's 0, 1, 2, 3, and I offset to create another 0, 1, 2, 3, and I created surfaces specifying the points of each of the triangles. So this triangle here is going from this red 1 to this black 0 to this red 2. And I put in all these triangles and surfaces, and then I do some offsets and do a planar surface between the offsets, creating different window sizes, and just add more options. Then when I click a surface and I say apply this script and do 5 by 5 divisions of the lofted surface that we did in the loft exercise, it just automatically creates that option. And when I say do 10 by 10, I get more divisions, and it calculates the geometry near instantaneously, and it has no limit on well, unless it crashes your computer. This last option took about 4 or 5 minutes to calculate, but it's going to do all of those surfaces just based on that same logic we started with, that you have each cell has 8 points and produce triangles or squares surfaces in that specific range. So there's a sort of zoom in shot. And I also did a random version where each cell is done randomly, and you kind of see some interesting variation happening there. Another way to think about plugging in data into Grasshopper this is just a gradient here, but we could take some solar information and make window openings less or greater based on that data of which facade they're on, whether they're south facing, and sort of direct the geometry to respond to data outside of traditional modeling, and introduce a level of complexity that will just be too difficult to model as we've done before in Rhino. So here's an example more of something smaller, where a friend of mine did this cool project, and he produced these surfaces, which then were made into 3D and had these teeth on them, so they could be laser cut from 2 pieces of card and then assembled together. And the teeth are all custom, so as long as you attach the teeth together, it will produce the surface that was specified at the beginning. So there's sort of assembling these teeth, and then they came together. I kind of helped him assemble that, and it just comes together like that. And it's sort of a nice project, which all of those teeth are parametrically controlled. So it's writing a computational definition to specify all the teeth, so that when it's all laser cut, it's made perfectly. And this was a test model that he made earlier. So in Grasshopper, you type Grasshopper, enter as in the command bar, like we've done for all the other commands, and it loads up Grasshopper. It's sort of a window that is separate from the Rhino space. So this is our Rhino space, that is our model. And then Grasshopper is a sort of separate interface where we're going to attach components and draw strings between the components, where each component is a command that we've used. So one component might be a circle, another component might be divide circle, another component might be put a cone on each of the division points and sort of attach it like that. If kind of getting really into Grasshopper, it is really nice to have dual monitors because it does take up a lot of screen space, and it's a worthwhile investment. So the files that you create in Grasshopper are different files when you go to save them from Rhino. So Rhino is .3dm and Grasshopper is .gh. And you have to kind of decide what's going to be inside of your Grasshopper space and what's going to be inside of your Rhino space. So when you start off, you might sort of specify a point or a curve and base everything off that point or curve. If the point is set to be 0, 0, 0, the way that I've sort of set most things to the origin, that can be specified entirely inside a Grasshopper. But if I set it as a point inside of Rhino and then I move that point, everything built on top of that point will move. But when I go to save it, it won't save the point because the point is in Rhino and the Grasshopper part is referencing that point, but that point isn't actually in Grasshopper. And I'll show you that later. So here's an example, and I've created sort of did screen capture of both sides of the screen, and a point, we'll start off, create a point and specify that point as 0, 0, 0. And you can see this sort of red X, which represents a Grasshopper point. Everything that we draw in Grasshopper will appear as red in Rhino, green when selected. And then I would add a circle kind of component. And each of these components has inputs on the left and outputs on the right. And left clicking on any one of these letters will sort of reveal more information about what each of those letters stands for. So in this case, this is a circle, and C is going to be the center point of that circle, N is going to be the normal, and R is going to be the radius. So I still can't see anything, even though I've set point as the center point of the circle. I create a slider, and that's currently set to 1, so I can't see anything there. But when I move it up to 100, I start to see the circle in Rhino. And I can just swing that slider to any number I want, and that circle would update. So then I could create a divide component and connect the circle to the curve to be divided, and then put another slider into the number of divisions. And you see that sort of be 20 divisions on that circle. And then just copy paste, create another circle with the radius to be 20 on each of the division points. So that creates 20 new circles, all with the center points of the division point on the original circle. And I have a slider for each one. This slider is the radius of the smaller circles. And if I do that again, I just end up with a lot of geometry in the model, and it's quite easy in Grasshopper to create a lot of geometry really fast. So I just, rather than have multiple sliders, if I wanted the same number to be controlled, back to kind of like in the Rhino model, when I want less points on a NURBS curve to have control over it, I want less sliders. So the division points, I can just use one slider and sort of plug this slider into both division points and this slider into both circles. That's currently set to 20. And if I change the number of division points down to 10, that will reduce the amount of geometry in the model because all of these circles are based on the number of division points. Therefore, it's sort of a bit cleaner here. And in this case, I sort of reduced the radius of the initial circle from 100 to 50. And that just updates everything because it's still a circle now of radius 50 divided 10 times with new circles created with a radius of 20. So the formula sort of remains in place. I can take any of these components if there's too much geometry in the model and either turn the preview off to make them invisible, which the shortcut is Control Q. I'm not a big fan of that shortcut because if you click that shortcut when you have the Rhino model activated, that will quit the program. It will ask you, are you sure? But Control Q is how you sort of hide a component. You kind of select multiple components, click Control Q, and hides them. If you want to turn them off, as in they are no longer affecting the sort of Grasshopper definition, that would be Control E, which is either enable or turn off. So all of the Grasshopper geometry, when it's in that sort of red mode, it's not clickable, or if you were to go back into your Rhino model, you wouldn't be able to snap to that geometry. It's sort of still in that sort of flexible, unfrozen geometry. And the term that is used is bake, to freeze the geometry at that point in time and bake it into your Rhino model, which you kind of select what components you want, say bake selected, and now that's curves or surfaces in the Rhino space. And after that, you can sort of leave Grasshopper behind or move it to the side and sort of change the settings and bake it again. So I uploaded three or four, I can't remember, three Grasshopper definitions to the Hackaday project page, so you can kind of see them. This is the loft tower that I'm not going to draw in Grasshopper that we did previously. But what I've done here is I've created a circle on the bottom, created a circle, another circle, you can't see that circle there. So two circles, divided them, I think 7 times, created a line between each of the 7 divisions on both circles. And then you can move a slider to move each one of these points along each one of these lines. And there's a NURBS curve that gets drawn on these 7 points. So the bottom curve of our lofted tower and the top curve are controlled by these 7 points, which we have a slider for each one of those points. And then it's lofted in Grasshopper, and then divided, contoured in Grasshopper, and then those contours are extruded in Grasshopper. So if I move any of these initial control points, then the whole model will update because it's all parametrically linked. I might not get time to go onto it, so I'll just cover it now, that you can add sliders to a remote and then have that remote in Grasshopper. So this is a screen capture from Grasshopper or from Rhino without Grasshopper, but this remote just has all my sliders. So you can see the top curve, the bottom curve, the 7 different points, change the numbers for them, as well as changing the floor thickness, the floor to floor height, and the tower height, overall height. And you can just move those sliders. And that file is on Hackaday. So if you want to mess around with that, that's there. So I'm going to jump into the software now, and we're going to do our first.
James, I put a link on the chat.
Okay, great. So this is Rhino, nothing loaded, nothing in the file. So if we type Grasshopper, it will load. I've kind of already loaded it, and I've nothing in Grasshopper. So to start, I just double click anywhere on the screen, and then double left click, and it says enter a search word. And that's sort of the command bar in Rhino. So if I type point, it will have the list of points. You can, of course, go through the menus and find each one of these components. But so I select point. So it's currently orange, which means it's unspecified. And I would right click and say set 1 point, which now if I click set 1 point, it's going to go back into Rhino, and you can see the command bar. It says, what is the point location? So if I type 0, 0, 0 and press enter, that's now specified, and that's got this red X, which says that's a Grasshopper point that's specified. to show you the difference that if I create a point in Rhino and I double click, do a point again, and go set one point object to reference. If it says coordinates, you need to sort of change the type here from coordinate to point. So point object to reference and reference that point. So in this case, the second one, I can select this point and move it in Rhino space, which that point in Grasshopper is moving with the point, where this one is not selectable. This point is just entirely in Grasshopper because I've specified it as 0, 0, 0. The problem with this, just to repeat what I said earlier, is this point, the link between this component and this point cannot be saved. You can sort of put a note here and say, specify one point when you open the model for the first time and have everything else sort of saved, and then just go back to the beginning of the model, and every time somebody opens it, they have to reference the point or reference the initial geometry. So I'm going to do, I think the exercise I first learned in Grasshopper, which we're going to type rectangular and pick this one kind of, this would actually be a rectangle 3-point, but I want this, which is a rectangular grid. It might be useful to kind of go through these menus, which if I went through vector and then grid, there's my different types of grids that I can select. So I've got the inputs on the left and the outputs on the right. I can sort of left hover over this, and this one's a base plane. SX is the size of the grid cells. SY is the Y direction. EX is going to be the extent, which is the number of grid cells that are going to be there on the X and the Y. So I can just plug in my point into this one. That's fine for a plane. And I can type slider, and I want a number slider. So that the default number slider is going to load with a floating point. I want to set it to integers, so I always have to sort of change it to integers. And then I also need to right-click and change values. And I don't want a minimum value of 0, I want a minimum value of 1, so there's always at least one point. And then a maximum value I'm just going to put as 100. And one thing I kind of find a little bit annoying in Grasshopper is if I click off now that's not saved, I have to click commit changes for that to, so that's now a slider from 1 to 100. So I can click into that one and into that one. And once I have that settings done for one time, I can just copy paste and the same settings. Now it's an integers slider from 1 to 100. I'm just going to left click from the end here and drag it into the rectangular grid component. So now we can see in the sort of background here, this grid that we've created. And this is the size of X and Y of each grid cell. And this is, sorry, this one is, this is the number of cells in our grid, and this is the size of each grid cell. So I'm fine with that one being 100. And if I want to go at a, if I want to drag and drag slower, I just hold down Control while dragging it, and it drags at a much slower rate, which if you're trying to control it is useful. So, and just to repeat that this grid is not clickable or snappable in Rhino because it's entirely in Grasshopper. So now I'm going to type circle, and I've got different circles that I can create. So there's a different component based on what I want the inputs to be. So if I want to just do a 3-point circle where I'm going to give it 3 points, A, B, C, I would do it that way. But I'm going to do a circle, and I want CNR. And you kind of just get used to these after a while. And CNR is wants a center point, a normal, and a radius. And I can look at the outputs of the rectangular grid. and I have the cell outlines, and I have the points. And I only really want the points in the exercise we're going to do. So I connect the points to the circle, and nothing has changed in my Rhino model as of yet. And I'm not going to worry too much about the normal, and I need to set a radius. So I can just copy and paste. I use Control-C, Control-V for the slider, and I'm going to plug this guy in here. And now I can see that I have these circles that appear in, I'm going to just double click this view. So so now this slider is operational, and you can see all of those circles moving based on changing this radius. And if I was to change this one, that would just add more cells to the grid. So I think what we're going to do now is we're going to use a distance command. And I think using distance in Rhino was really just to check the distance of something. But here we're going to use it slightly differently. So I want the distance from this point that we created, which is a point that I can drag. And I want the distance from this point to the center points of each of those circles. So on the rectangular, so the circle, the C is the curved geometry, that is the actual circle. But this P over here on the grid is the center point of that circle. So I want the distance between that one and this is that point. So that one. And now if I left click over here, I can see there's 100, if I read that sort of text, there's 196 locally defined values, which means that it's got a list of the distance, starting with the first one, of every single distance between this point and all of that information. And if I double click and I type panel, just as an optional step, and I right click or left click and drag that into the panel, I can see what information is coming through there. And there's lots of info there. So with this distance, I'm going to put a multiplier, which is multiplication, and use another slider. And I want basically to just put a multiplier on the distance. And I'll show you why I did that in a second. I'm just going to delete this to get it out of the way. And now I'm going to drag this circle out here. And rather than use this radius to control the radius of all of these circles, I'm going to use this number. So I can't see anything right now because it's either too big or too small. And if I move this slider, I can see making it bigger does nothing, but there sort of brings the geometry into focus when it's around 1. So I'm going to firstly change this to a floating point so that I can go to less than 1, and then change the values on the slider where the minimum is 0 and the maximum is 1. So this is just going to be numbers between 0 and 1. And then I can lower down this multiple. And this is sort of creating an attractor point to control the radiuses of all of these circles. So then moving this point updates all of the radiuses in here. So the grid, the rectangular grid, these lines are still on. And to turn them off, I can right click and turn preview manually, or Control Q. If you select multiple objects and right click and click preview, it only turns off one component at a time. So that's why the Control Q is useful. If you need to do multiple components, Control Q will turn preview off on all selected components. And I'm not going to cover it because we won't have time, but for later, if anyone's interested, if you want to do multiple points, you basically have to multiply the distance of each center point to each point by each other. And then this multiplier needs to be way smaller. And you basically can have multiple attraction points within your model. You could also, if you guys want to try it out, do a curve and do the distance between the curve, the nearest point, sorry, the distance between the curve and the center point of each of those circles. And then it's an attractor line where you're doing the sort of same model. But if we're going to open Rhino and Grasshopper now, and everyone can have a chance to try this out and ask questions just at creating this much geometry. You could also extrude each of those circles, and as just one extra command, where you just extrude, and we'll take one of these 1 to 100 sliders, copy paste it, put it into the distance. And, oh, sorry, it needs to be a vector. So I typed, rather than just have a number, a vector, so I typed a unit Z vector, and now that should multiply. Okay, I must have done something wrong. Well, anyway, everyone can start drawing, and I'll just figure out what I did wrong here. And if there are any questions, I'll have the chat open. Oh, sorry. They were extruded. I just couldn't see that in the top view. And I could also connect the, rather than use a number, connect my distance, this kind of more complicated list. I'm going to just put in another multiplier, but take that number, put that in there. And now the height of each of those extrusions is based on the attraction point. How do you delete connections between nodes? So just right click where the connection is. And on this one, fourth down is disconnect. And if you have multiple things connected, you hold shift down if you want. If you connect something, it replaces it. But if you hold shift down and then you release the left point, that would add multiple points. So if you right click on them, disconnect, and it will give you a list of all connections, and you can just disconnect them there. Hope that answers your question, Brent. If Matt or Joe want to share your screen, maybe we can just see how hard this is, or I'll answer any questions.
Yep.
Oh, okay. So you're creating.
I'm sure what that was.
Yeah, there's different types of sliders that we can do, but the simplest slider is a number slider. So we're probably better off just sticking with that. So the P is going to be a base point, or yeah, you can set it randomly, I guess.
So you can say.
You can do it the way you've done it. I mean,
I think it just defaulted. I didn't set one over there at all. It just defaulted there, I guess.
So set one point is.
Screen. So how do I set that then? I pick it over here.
Right click. And then see the set one point, set multiple points below.
Oh, yeah. Okay. So then here I would go.
So the command bar is asking you for point location.
So I can just type that in, right?
Yeah. So probably don't copy paste until you.
Until I set my extents.
Yeah.
Right?
And you notice how it was red there? That's because you can have a floating point for the size of each of the grid cells, but you can't have a floating point for the number of cells.
Okay.
You can have 0.2 cells.
Gotcha.
So that wanted to be the EX and EY wanted to be integers.
Okay, so it tells you when you have a clash between.
Yeah, it basically
setup and.
Sometimes you can have clashes and you can tolerate the clashes, but it will go red.
And the value is where it starts when you open it. Is that what that is?
Yeah, that's its current value, but you can manually change that to whatever you want. So on your Rhino space, you're really zoomed in, but the geometry, I think, is there. If you just maximize your top view and zoom out.
Sorry. Yep. Wrong view.
Yeah, there it is.
Okay, so that makes sense. Make sure you're in the right window.
And one issue is if you have sliders with really big numbers and you already have a model with lots of things going on it, and you move that slider too high, such as the tower I showed you with tons and tons of divisions, your computer will just crash. I mean, it will attempt to make the calculations you try to make it get it to do. So
that's a safety feature, really, right? Set your limits carefully.
Yeah.
So these are the points, and these are the outlines of that.
Yeah. So with the circle, that would be a circle that you're going to right click and set one point to set one circle. We want a different component, which is the CNR circle.
Center normal radius.
Yeah. We want to use the points, not the cells.
So these big, oh gosh, I'm going to make all the mistakes here for you, James.
That's great. I mean,
okay. So that's my center. My normal defaults to positive on that plane. Is that what that is?
Normal in this case is going to just default to sort of vertical. We're not going to worry too much about the normal right now, but if you were to do, let's say, a sphere and then divide points on a sphere, the normal would be pointing away from the sphere on every one of those points, and you could create a circle, all the circles on the division points tangential to the surface of the sphere.
Okay. But when you're in 2D, it doesn't matter, right? It all is in the same plane.
Yeah,
essentially.
We're just going to do this in 2D because, but the same, it would work.
Okay, so that's that. I need to set another point too, right?
Yeah, and this time we're going to set the point differently, where you create a point in Rhino and reference it.
Okay, so and then here I just set one point and I pick that point. So
yeah, but you need to just check what your command says, and make sure that it's selecting a point and not a coordinate. Yeah, type point. So that's fine.
okay, so that's my point now. So then I'm going to do distance from here to
I'm just curious how everyone else is doing. Is anyone near done, or is anyone really struggling? Type in the chat.
Leo says poorly.
Do you have any questions, Leo, or I'm happy to answer anything? Always check the sliders that they save the settings, because I always click off and it doesn't change the settings the way I want.
shows my radius.
Okay, there's two questions. I'm going to share my screen again and okay, so on how do you create a slider? So in Grasshopper, so I've got my screen shared again for anyone just listening. So double click, and that's how I kind of get the where I'm going to type commands into. It says enter a search keyword, and I just type slider, and it gives me a list of sort of matching results, and it's the number slider that I'm after. Alternatively, from the parameters menu, input, and it shows me all a range of inputs, and number slider is there on the menu bar. And then right clicking on any slider is going to have the slider type, which is how I'm going to change between floating points and integers, which, as I said, is important for the number of cells in the grid, because I can't have a 2.5 cells. And then the values, I want to change the minimum and the maximum number. And then I have to click commit changes for it to actually work. The val is just its current value, which I usually move with the slider, so you don't need to worry about entering it here. On deleting connections for Michael, if I right click on any component, and I'm sort of hovering over the inputs or the outputs, and I right click and I get the menu, and I have this disconnect third down in this menu, and then I just left click on that, it will disconnect it. And as for a quick overview, we're creating a point as our initial point, then a rectangular grid, which if you're looking for things in the menu, the rectangular grid is under vector and types of grid. Then we're creating sliders. You can create 4 sliders if you want. I just created 2, but you want to set the sliders to integers, not to floating points, and set the limits to 1 to 100. And then left click to drag the slider into S of X and S of Y, and into E of X and E of Y. Then we want to create a CNR circle. So when we type commands circle, and don't click the other types, the 3-point circle or this circle or any of these other ones. So we need the circle CNR, which is center point normal radius. And we want to connect the points of the grid to the circle, which creates a circle on every grid point. And just to get started, we kind of copy paste a slider and set the radius to the slider number. But then we're going to create a distance component. So we double click and type distance. And we can get this one with the ruler on it. And it wants the distance between 2 points, A and B. So we can set the grid center point as A, and B is a point that we're going to set in the model where we want to reference an actual point. So we right click, set one point and make sure it's not setting it as a coordinate, but is actually selecting the point as an object. And then given these distances as a list of numbers are going to be really big or really small, we use a multiplier and a slider to scale all of those numbers proportionally, and we can control it with this slider. Connecting this list of numbers into the circle component connects this list of distances and this list of center points, which this list of circles on those center points connects the two lists together and makes what we want. And then I've just added an extrusion with a z vector with another multiplier, another distance, but that's not necessary.
James, how did you get the z vector?
Unit and then z, people say. And that's basically a component that's by default set to 1 unit in that direction, and you just set a multiplier to multiply that as you wish. But, or I set a slider which multiplies it. A lot of Grasshopper classes might be 8 weeks long, and an entire section would be on vectors. So, but did you finish it, Matt? Or?
Yeah, I'm still working on my extrusion.
Yeah. We might just jump back into watching another exercise, and then that will be sort of the conclusion of the lecture tonight. And you can kind of figure things out later, and I'll be happy to answer questions afterwards or anytime you want. But so if everyone kind of, I guess, stops drawing. Oh, that's the pace for everyone.
I'm just asking. What are we doing on pace for everybody?
So I just did Control A inside of Grasshopper and delete. So I'm going to create 2 NURBS curves, the same as I kind of did a lofted tower. And I could, if I wanted, do what I showed you in the slides and create a parametric lofted tower, but I'm not too interested in that side for this exercise. So I'm just going to create a quick one in Rhino, and I'm going to just do a box that's 100 by 100. I don't really care about the scale. And so I'm just going to create any so I'm kind of drawing this in Rhino just to be faster. So that's kind of essentially last week's or whenever we did surfaces exercise. So I just have a single surface lofted sort of tower. If I type surface in this way, these kind of little tiny components that have no inputs and no outputs, they're just if you want to bring geometry from Rhino in. So we did that with the point. So I can set one surface and that's it. And it kind of clashes because my Rhino surface and my Grasshopper surface are clashing. That's this sort of red-white. So if I just select my surface in Rhino and just type hide, that turns it off. And now I have this Grasshopper surface. And if I wanted to really get into that surface, I could create a height vector and sliders and do things. But Right now, we just want to learn how to divide that surface into panels and then do stuff with the panels. So divide surface is a command, but the problem with that for what I want to do is it's not going to number the division points as a list in the way that I want them to be numbered. So I want two commands. One is going to be called domain squared. Sorry. Domain. Numbers and quantities. So one of them is going to be isotrim, and the other is I'm just going to load a file. Since I did it earlier. I'm going to recreate what I did there. So, divide domain, and isotrim as the surface. So using these two commands, the first one is divide domain, and this one is isotrim. It comes up with a different name here, but that's fine. And I want to take this surface and divide that surface and also do this isotrim command. So I'm connecting the surface into the base domain here and the base surface here. I want two sliders again, the way I had them before, number sliders. I want to change the slider type to integers, and I want to change the limits and commit those to changes. And I'm just going to keep U and V the same. I don't really need them to be different. And the divided domain, I'm going to use that as the D here. So that should, so I'm going to select this surface because they're currently clashing and turn off preview because this surface is creating a surface in Grasshopper. And then this is also creating a surface. So that's two surfaces. That's what was clashing. And I can see my divisions on the thing. And as I increase this slider, I just increase the U and V, which is the iso curves. And that's my cells here. And then in Grasshopper, they use this command called a brep, and a brep stands for boundary representation, I think. And that's sort of in place of a polysurface. It's kind of a more complicated component that allows a lot more kinds of information than just polysurface, but we're going to use it sort of essentially or well, if we were to use it, it's essentially going to be the same thing for a lot of basic commands. So these are, if I was to right click and type bake now, just to show you what that looks like even at this scale. So now that would create a whole bunch of separate surfaces. So if I was to deconstruct BREP and connect the surface to deconstruct each of them, that will give me faces of the BREP, so faces of each one of those surfaces as a list, edges, and vertices. And I'm going to delete this because I don't need it. And so when I'm doing things in Rhino and Rhino modeling, I might just select points manually, but when I'm doing them in Grasshopper, I need a way of doing them sort of more computationally. So everything is in lists, and I kind of showed you the panel to see what's in that list. So I want to use the command list item, which says the number of the command. And each one of these lists is 4 points on each one of these cells. And then firstly, the list of each one of the kind of cells. And then a secondary list of each of the 4 corner points on each one of those cells. So selecting the vertices, if I want to create the list item for that, and I, which is the number on the list, and I can basically copy paste and make 4 of these. And then the first item on any of these lists is always 0. So set integer to 1 for the second one, set it to 2, set it to 3. So if I left click each of them, it's going to show what it's selecting in the model over here. So that is basically 0.0 on every single cell there, 0.1, 0.2, 0.3. And if I turn off the preview for that, turn off the preview for that, and I just have the points, and I do a surface from a 4-point surface, which can be a 3-point surface if I don't fill out the D. But so 4-point surface, and I'm going to use any number of these points. So that's going to be point A, that's going to be point B, that's going to be point C. And you can see there it's already started to construct a triangle on every single one of those cells that goes from those 3 points. And if I was to change, I'm going to put this one into C, so it's going to change the point. It's going to draw a different triangle. And that's sort of how we divide the tower. And just as one last point for the sort of advanced method, if I was to offset a surface, and I want to go back to this initial surface, and that's what we're going to offset. That creates a new surface, and then I'm just going to copy and paste this whole, actually, sorry, I don't want the last one, but just copy and paste the majority of this part above. And I want to do the offset surface, the same thing. So I just need to change what was initially the first surface and just replace that. So now this whole command is the offset surface and the 4 points. And then these 4 are for the initial surface. And I have 2 sliders here and 2 division points of each of the surfaces. I kind of want them to be the same. So I want to replace the U and V of both of them to be controlled from the same slider, and then just delete this slider. So now this slider is the UV division of both the surface and the offset surface. And if I now want to create my 3 points, and I'm just going to Control Q to turn off all those points because they're kind of in the way. And I can turn off this offset surface because that's the whole surface. and change of our three-pointed surface, one of the points to be on our offset surface. And I must have done something wrong. Oh, actually, I know what I've done. I have no distance on the offset. So let's just give it a distance. There we go. Let's just increase the amount of geometry it's making. So now we have, in this part, an inner surface, an outer surface. We have 4 points that we could choose from on the inner surface, 4 points we could choose from on the outer surface. And we've just drawn a triangle between 3 points of the 8 points. And we can pick whatever 3 points we want. And that's kind of the second exercise. Let me know in the chat. I don't know if this is getting too much for the pace. And then if we had created the initial surface with Grasshopper, we could change the height and do everything as well. So we can still control the offset and make that sort of really pointy. It actually looks like a Thomas Heatherwick project, but get really small. And you can kind of see, and probably goes without saying, that would be really hard to do without Grasshopper. All those angles and just everything. And then at the end, right click whatever we want and shift if we wanted multiple components, but right click, bake. And that brings all of those surfaces into Rhino. And if you wanted to do something else with them, like a 3D printer or something, obviously you need to get it out of Grasshopper and into Rhino. So this baked geometry is no longer adjustable or flexible. The sliders only control unbaked geometry. So that's kind of what we wanted to cover, what I wanted to cover. I'm going to stay around, but now you can finish off the first exercise, try the second exercise. Let me know, again, Matt's question, how's the pace, and any questions people have.